write it to you, Ab, but today we're going to factor. So, not saying, just saying. Alright, ready? Cam's dad joke. So, 4 keys to factoring. And again, I'm not going to spend a lot of time on these because you've seen almost every single one of these ways of factoring, probably with the exception of cubics. I don't remember if we did cubics last year or not, but the other kinds of factoring you've seen. Okay? So first and foremost, always look to see if there is a greatest common factor. That's your first method, your first look, your first observation, every single factoring problem. Okay? Is there a greatest common factor? Okay. So you look not only at the numbers, okay? So what's the biggest number that goes into 8 and 20? What is it? 4. Okay? But you also look at the variables too. Okay? What's the biggest factor that goes into x squared and x? X. So you put those two together and you get 4x goes out in front. 8 divided by 4 is 2. X squared divided by x is x. 20 divided by 4 is 5. X divided by x is 1. So 8x squared plus 20x factors greatest common factor lead to be 4x times the quantity 2x plus 5. How do we check GCFs? It's an in your brain one, and how do you do it in your brain? You have one, I know. How do you do it? Just multiply it back through. Multiply it back in. Distribute it back in. 4x times 2x is 8x squared. 4x times 5 is 20x. Okay? So you got that one. Okay? Second thing. Don't forget what a difference of perfect squares looks like. Okay? There are 3 parts to a difference of perfect squares. There's a perfect square in front. There's a perfect square at the end. But most importantly, there's a what in between? Subtraction sign. If it's an addition sign, you cannot factor it. Okay? 9x squared plus 1 does not factor. Okay? But 9x squared minus 1 does factor. Now, I think I referred to it last year like this because I've been referring to it for years like this. Okay? It's a hybrid of the butt cheeks. Okay? Meaning this is going to factor into those. Okay? So what times what, and they got to be the same, gets me 9x squared. 3x and 3x. What times what, and they got to be the same, factors to be 1. 1 and 1, right? Okay? And then one of them has got to be plus, one of them has got to be minus. Okay? Another way of thinking of that, okay? Take the square root of the first term. Okay? The square root of 9x squared is 3x. Take the square root of the second term. The square root of 1 is 1. That's your two parts. Okay? One with a plus, one with a minus. Okay? Now, sometimes, and I will tell you this, and this will be a common theme throughout the day, sometimes after you GCF, then it becomes the difference of perfect squares. Okay? Or then it would become a perfect, or a square, or a factorable trinomial. Or it would become something else. Okay? So you are going to, now that you guys are all, older, more experienced mathematicians, okay, you are going to factor until you can't factor anymore. Okay? That's what it means to completely factor something. Okay? You're going to go until you can't go anymore. Okay? Third thing, basic product of two binomials. Okay? That's the straight up butt cheeks one. Okay? So that's where you're just kind of guessing and checking and making sure things work out. And so you're going to start with a couple of parentheses. What times what gives me 2x squared? 2x and x. Okay? So 2x and x. What times what gives me 20? 5 and 4 is one of them. 2 and 10 is the other one, or another one. 1 and 20 is the last one. Okay? Me, I like to start in those middle two. Okay, the ones that are the closest to each other. Because 7.863 times out of 10, it's going to be those two that are right tight in the middle. Okay? Alright? So I would probably go here 5 and 4. Okay? Because then my outers here give me 8x. My inners here give me 5x. And when I subtract them, I get 3x. But I need the negative sign to be on the bigger one. So negative there, positive there. Okay? Cubics is the fourth way. And cubics, we are going to save... Oh, no, I guess now we're not saving it. I guess we're doing it today. I thought we were saving that for Monday, but no. We're going to do it today. Today. Okay? Okay? So with cubics, there are two special formulas that I feel are note card worthy. Wink, wink, nudge, nudge. Okay? And that is a cubed, and I'll go plus or minus b cubed here. That's going to equal a, actually here, let's do this. Let's be smart about this, Linsmeyer. Let's go all crafty. Oops, wrong way. Okay? So if it's a cubic plus a cubic, okay, so that would be a cubed plus b cubed, then that's going to factor to be a plus b is your first factor, a squared minus ab plus b squared is the other factor. If it's a cubed minus b cubed, then it's going to be a minus b is your first factor. A squared plus ab plus b squared is your second factor. Okay? Again, I don't expect you to memorize those two formulas because I'm giving you a note card to use on the tests and quizzes, final, all the way through. Okay? So, there they are. Okay? So let's factor completely. You guys want to try them on your own, or do you want me to go through the first two? Go through the first two? Okay. So, looking at numbers here, 98 and 14. For 14, my choices are 1, 2, and 7, and 14, right? Okay. 98. Does 14 go into 98? How many times? 7 times? So I guess it's 14 then. Agree? Doesn't hurt to start with a smaller number, okay, when you're to figure out the factors. And then try biggest to smallest. What if, just for happenstance, what if Luke decided 2 is his biggest number? So he only factored out at 2. And so he was left with 49x minus 7. Right? He factored it. Do we all agree that he factored it? Yeah. Okay. So why isn't he right? Because it's not complete factored. Yes, factored, but not factored completely, because there's still a 7 that can come out of 49 and a 7 that can come out of 7. Okay? So when you factor completely, everybody would get the same answer. Okay? All right? So, looking at number 2. Is there a GCF? Because that's what you got to ask yourself every first time, every time. 2? 2x? 2x. Do we agree to 2x? Yeah. Okay. All right. So we agree with 2x. So if I factor out a 2x, then I'm left with what? 6x squared plus 11x plus 4. Okay? Now what do I have to ask myself? Can I factor that trinomial, right? Okay? Because I know I can't factor out any more GCFs because they all don't have an x term, or an x part, I should say, and there's no number that goes into 6, 11, and 4. Okay? So let's try and see if it's factorable. What do you want to try first? 3 and 2 or 6 and 1? 3x, I should say 3x 2x or 6x 1x? 3x 2x, okay, because there's those middle ones. Okay. What do you want to do with 4? 2 and 2? Okay. If I do 2 and 2, on the outside I get 6x. On the inside I get 4x. Does not add to be 11x. Okay, so I don't like that one. 4 and 1. You want to go 4 first or 1 first? 1 first? Nick, did you just say it doesn't matter? Okay, well let's see. Okay, so let's go 1 first and 4 second. Okay? 1 and 4. Now, on my outers, I get 12. On my inners, I get 2. Add those together, gives me 14. Doesn't work. Okay? So now let's flippity-floppity. 4 here, 1 there. That gives me 3x and 8x. Add those together and I get 11x. So they both have to be positive. Yep. So yes, Nick, order matters. Yep. And if, let's say for happenstance, or for in case it didn't work, what if 4 and 1 didn't work in that order. Then what would have we had to do? Then we would have had to go on to 6 and 1 and tried them all over again. Yeah. Okay? But, so there is our answers for the first two. Okay? You try those two. Oops, I almost said number 1. You need more time or not?
A little bit.
A little bit? Well, bet. Alright, what did we do first one? Or third one, I should say. GCF or no GCF? GCF of what? 5g cubed. What's left over? Plus 16. Okay. Can I factor g squared plus 16? No, I cannot. Okay. So, but why can't I? Because it's the plus sign. Okay. Number 4. GCF? What? 3x. So that leaves what left over? 25x squared plus 10x plus 1. Is that 25x squared plus 10x plus 1 factorable? Yes? Okay. What does it factor to be? 5x plus 1 and 5x plus 1. Now, I would accept this as an answer. Okay. I would also accept here, because the 5x plus 1s are the same, I would also accept that as an answer. Like, what do you mean? Which of these two? I don't care. Yeah. Later on, you're almost gonna want to leave it like this, because we might, when we get to dividing, you could possibly divide stuff out when it's factorable, you know? So, yeah, but you can do the same with it. You just cancel all the exponents, you know? Yep. Okay. Yeah, buddy. GCF in the first one? 2x squared? Yeah? Okay. What's left over? 4x squared minus 9. 4x squared minus 9, is that factorable? Yes, because it's a perfect square minus a perfect square. So that becomes 2x squared times 2x minus 3 times 2x plus 3. Bang. Okay. GCF in the sixth one. 4x. Sneeze building. What's left over? X squared plus 2x minus 5. X squared plus 2x minus 5. Factorable? Not factorable. Yea or nay? Two numbers that multiply together to be negative 5 and add to be positive 2. That's a nay. Yep. So that becomes a done did factored. Okay. Nick, just for you, there's those cubic formulas again. Okay? So that you can easily understand them, as opposed to my minus, plus, plus, minus. I wrote them as plus or minus, and then minus, plus. I put them together. I sandwiched them together.
Oh, the one there.
Yeah.
Okay.
Okay? These are there. I wrote them for you split up this time. Okay? Whoa, that's kind of bright. Okay? So, let's try and factor this bad boy completely. Okay? First off, first question you got to ask yourself is self GCF. Is there a number that can go into 27 and 125? Three, right? Does 3 go into 125? No, doesn't. Okay? So that's a no. That's a no-go on GCF. Okay? But, is it a difference of perfect squares? No, because of the plus. Okay? So then, you got to look, so after you looked at GCF, and then after you looked at difference of perfect squares, then now you got to look at cubics. Okay? Is 27x cubed a cube of something? Yeah? What is it a cube of? 3x quantity cubed, right? Because 3 times 3 times 3 is 27, and x times x times x is x cubed. Okay? Is 125 a cube? 5 cubed, yep. So then this part right here, this 3x, that's your A. This 5, that's your B. So 27x cubed plus 125 factors to be, I'm going to follow this top formula here now, 3x plus 5, because that's A plus B, okay, A plus B, times A squared. So 3x times 3x is 9x squared minus A times B, 3x times 5 is 15x, plus B squared is 25. That's it. Because that second trinomial is not factorable. Okay?
So if it is, we just go further.
If it, what do you mean if it is? It never will be.
Okay.
Yeah. Yep. It only, I shouldn't say that. It only will be if you screwed up somewhere along the way. Okay? Yeah. But in that, if you apply that cubic formula, that trinomial is not factorable. Okay? Now, we're going to tap the brakes here a little bit. I'm going to move this up a little bit so that I can still have the formulas on there and you can still try it. Try it. First thing that you got to do. What are you going to do first? GCF. What are you going to factor out?
2d squared.
Can I factor out a negative 2d squared?
Sure.
So what's left over then? 8d cubed minus 1.
Why didn't you just do that negative there, though?
Why can't I factor it out and get rid of it? Then I got a positive a value and, you know what I mean? Just tap the brakes, you'll see it, it'll all come out in the end. Okay? So, what's my a term? 2d. 2d is my a term. Right? Because a cubed is 8d cubed. What's my b term? So this factors to be negative 2d squared times the quantity 2d minus 1 times the quantity 4d squared plus, because it was minus, we switch it to plus 2d plus 1. Okay? And that, I hate to break it to you, Freddie, is much cleaner than the way that you probably did it.
2d squared.
Right?
And then parentheses negative 2d plus 1.
Yep.
Other parentheses 4d squared minus 2d plus 1.
Right. But see how mine's much cleaner?
I don't see it.
Would mine still be technically right? Would
Should it be
you mark it
minus
right or would
2d?
it be wrong?
Shouldn't it be minus 2d?
Here? No. Because this is a subtraction sign. So when it's a subtraction sign in between here, then that one goes to plus. Okay?
So let's say that we didn't take that negative out when we raise common factor.
Mm-hmm.
Wouldn't we just do the same thing basically, just with the addition amount? So it would be 2d squared, parentheses, 2d plus 1, parentheses, 4d squared minus 2d plus 1.
Except what Freddie did wrong was when she multiplied here,
Yeah.
okay, she didn't bring the negative along with the negative 2d.
Okay. So then
This trinomial should have been the same for both.
Oh, okay.
Mhm. So it just cleans up, by factoring out the negative sign, it cleans up this first binomial.
Okay.
I see.
Okay? Now, I'm going to give you an option here. Okay? The option is this. Option A. I give you homework that you can only do part of right now. I mean, really, you could do the whole thing because you know how to solve equations after you factor. But I could give you the homework now, and you'd have homework. Option B, I could give you the homework on Monday, and it would be due on Wednesday. Option C, I could give you the homework on Tuesday, and it would be due on Wednesday.
If we get it today, is it due Wednesday or Monday?
It's due Wednesday.
Monday.
It's due Wednesday no matter what. So, all right, then you don't have any homework this weekend.